What if Earth is not the best planet for life? For billions of years, Earth has been the only world we know with oceans, forests, animals, and humans. But scientists are now asking a strange question. Could there be planets out there even more suitable for life than Earth? Recently, astronomers identified a distant world that sparked huge excitement. It appears close to Earth size. It orbits a star similar to our Sun. Its year may be close to Earth's year, and it could be in the habitable zone, where liquid water might exist. Some headlines call it Earth 2.0. Others suggest it could be better than Earth. But is that actually true? Or is this another case of space science turning into viral hype? Earth seems perfect for life. It sits at the right distance from the Sun, not so close that oceans boil away, and not so far that everything freezes solid. This region is called the habitable zone, or the Goldilocks zone. But Earth's habitability is not just about distance. Earth has a protective atmosphere. It has liquid water. It has a magnetic field that helps shield the surface from dangerous solar radiation. It has plate tectonics, which help regulate climate over long periods. It also has a large moon that helps stabilize the planet's tilt, creating relatively steady seasons. All of these things work together to make Earth a living world. But here is the surprising part. Earth may be perfect for us, but that does not mean Earth is the best possible planet for life. Scientists call these possible worlds superhabitable planets. Part 2. What does better than Earth mean? A superhabitable planet is a world that could be more favorable for life than Earth. That sounds impossible at first. After all, Earth is the only planet we know with life. But researchers have suggested that a better planet might have certain advantages. It might be slightly larger than Earth, allowing it to hold on to a thicker atmosphere. It might be slightly warmer, creating more stable environments for life. It might have more shallow oceans, islands, and coastlines, increasing biodiversity. It might orbit a star that lives longer than our Sun, giving life more time to evolve. And it might have stronger protection from radiation and a more stable climate. In other words, a planet does not need to be identical to Earth to support life. It might actually be better if it is just a little different. Part 3. The planet behind the headlines. The planet causing all this excitement is located about 146 light-years away. That means the light we see from that system today began traveling toward us 146 years ago. In human terms, that is incredibly far, but in cosmic terms, it is relatively nearby. What makes this planet interesting is that it appears to share important similarities with Earth. It may be only slightly larger than our planet. That matters because planets close to Earth size are more likely to be rocky rather than gas giants like Jupiter or Saturn. It also orbits a star that appears similar to our Sun. That matters because the type of star strongly affects whether a planet is habitable. Some stars are unstable and blast their planets with radiation. Others burn out too quickly. Smaller red dwarf stars can last for a very long time, but many produce powerful flares that may damage planetary atmospheres. A Sun-like star gives scientists a familiar comparison. Even more interesting, the planet's orbit may be close to Earth's. Its year could be similar in length to ours. So when scientists saw these clues, Earth-like size, Sun-like star, Earth-like orbit, it immediately became a promising candidate. But promising does not mean proven. When people hear habitable zone, they often imagine oceans, clouds, forests, and alien life, but that is not what the term actually means. The habitable zone is simply the region around a star where liquid water could exist on a planet's surface, if the planet has the right atmosphere. That last part is critical. A planet can be in the habitable zone and still be lifeless. Mars is near the edge of our Sun's habitable zone, but today it is cold, dry, and hostile. Venus is near the inner edge, but it is a nightmare world with crushing pressure, toxic clouds, and surface temperatures hot enough to melt lead. So being in the habitable zone does not guarantee life. It only means life might be possible under the right conditions. For this newly discovered world, scientists still do not know the most important details. Does it have an atmosphere? Does it have liquid water? Does it have a magnetic field? Is its surface rocky? Is it frozen? Right now, we do not know. Some estimates suggest it could actually be much colder than Earth. So calling it better than Earth is exciting, but premature. The real story is not that scientists found paradise. The real story is that they found a world with enough Earth-like traits to deserve serious attention. Part 5. How scientists find distant planets. One of the most amazing parts of this discovery is that scientists usually cannot see these planets directly. They are too small, too dim, and too close to the bright light of their stars. So astronomers use indirect methods. One method is called the transit method. If a planet passes in front of its star from our point of view, it blocks a tiny amount of starlight. That small dip in brightness can reveal the planet's size and orbit. Another method is called radial velocity. As a planet orbits a star, its gravity pulls on the star slightly, causing a tiny wobble. By measuring that wobble, scientists can estimate the planet's mass. Together, these methods can reveal whether a planet is likely rocky, how far it is from its star, and whether it might sit in the habitable zone. But there is still a huge difference between finding a planet and knowing what it is actually like. To know if it could support life, scientists need to study its atmosphere. That means looking for gases like water vapor, carbon dioxide, oxygen, and methane. These gases can leave fingerprints in starlight when a planet passes in front of its star. If future telescopes detect the right combination of gases, it could suggest that a planet has conditions suitable for life. Part 6. What would a better Earth look like? Imagine a planet truly better than Earth. It might be slightly larger, giving it enough gravity to hold a thick, stable atmosphere. It might have warmer average temperatures, making more of the surface comfortable for life. It might have more islands and shallow seas, creating rich environments where life can thrive. It might orbit a calmer, longer-lasting star. Our sun is stable, but it will not last forever. In about 1 billion years, the sun will become bright enough to make Earth much less friendly to life. A smaller orange dwarf star could live much longer than the sun, while still being relatively stable. That would give life more time, and time matters. On Earth, simple life appeared billions of years ago, but complex life took a very long time to evolve. A planet with stable conditions for longer could give evolution more opportunities. A better Earth might also have stronger protection from radiation, active geology to regulate climate, and enough water to support life without becoming a deep global ocean. It would not need to be identical to Earth. It would need the right balance: water, atmosphere, energy, protection, stability, and time. It is easy to think of Earth as a perfect paradise, but Earth has had a violent history. There were times when much of the planet may have been frozen. Massive volcanic eruptions changed the climate. Asteroid impacts triggered mass extinctions. Oxygen levels changed dramatically. Continents moved, collided, and broke apart. Life survived, but it was not always easy. Earth has repeatedly pushed life to the edge. A superhabitable planet might avoid some of these extremes. It might have a more stable climate. It might receive steadier energy from its star. It might have better protection from radiation. That does not mean such a planet would be peaceful or perfect, but it could offer life a better long-term environment. This is why scientists are willing to ask whether Earth is not the ultimate model of habitability, but just one example. So, could this distant planet have life? The honest answer is maybe, but we do not know. There is no evidence yet of plants, oceans, animals, oxygen, cities, radio signals, or alien civilizations. All scientists have right now are clues. Size, orbit, star type, possible temperature, possible habitability. That is not enough to confirm life. But life on Earth teaches us something important. Life is incredibly resilient. Microbes survive in boiling water, frozen ice, acidic lakes, deep underground, and near deep-sea vents without sunlight.
This means life may not need perfect conditions. It may only need liquid water, chemistry, energy, and enough time. If this planet has an atmosphere and liquid water, microbial life might be possible. But complex life is much harder. Animals, plants, and intelligence require long-term stability. Even on Earth, intelligent life appeared very late in the planet's history. So a habitable planet does not automatically mean advanced life. It may mean microbes, or nothing at all. That uncertainty is what makes the search so powerful. Part 9. Why this discovery matters. Even if this planet is not better than Earth, it still matters. Every Earth-like candidate helps scientists understand how common habitable planets may be. For most of human history, we did not know whether planets existed around other stars. Now we know they are everywhere. Thousands of exoplanets have been discovered. Some are giant gas worlds. Some are scorching hot. Some are frozen. Some are strange planets unlike anything in our solar system, and a few are rocky worlds in places where liquid water might exist. Each discovery brings us closer to answering one of the biggest questions in science. Is Earth rare, or is the galaxy filled with worlds that could support life? If scientists eventually find many planets with atmospheres, water, and stable climates, then Earth may not be unique. And if they detect gases that strongly suggest biological activity, it would be one of the greatest discoveries in history. It would mean life happened somewhere else. That would change everything. But we have to be careful. Space headlines often exaggerate. A planet being potentially habitable does not mean it is habitable. An Earth-sized planet does not mean it is Earth-like. A planet in the habitable zone does not mean it has oceans. And better than Earth does not mean scientists found an alien paradise. Usually, scientists are much more cautious. They may say a planet is interesting. They may say it is promising. They may say it deserves more study, but that is very different from saying it is a second Earth. The truth is more complex and more fascinating. We are not finding perfect copies of Earth. We are finding strange worlds that might teach us how planets work, how atmospheres survive, and how life might begin. Some may be frozen. Some may be ocean worlds. Some may be volcanic. Some may be completely dead. And maybe, somewhere among them, one world is alive. Part 11. Could humans ever go there? At 146 light-years away, this planet is far beyond human reach with today's technology. Even our fastest spacecraft would take an enormous amount of time to get there. To reach another star system, humanity would need revolutionary propulsion, perhaps fusion engines, antimatter drives, laser-powered light sails, or technology we have not invented yet. So for now, this planet is not a destination. It is a scientific target. We may never walk on it, but we can study it. And studying it could answer questions that matter deeply. How common are Earth-like planets? Can rocky planets keep atmospheres for billions of years? Are habitable worlds rare or common? And most importantly, are we alone? Part 12. What happens next? The next step is more observation. Scientists need better measurements of the planet's size, mass, orbit, and temperature. They need to study its star more carefully. Most importantly, they need to search for an atmosphere. If future telescopes detect water vapor, carbon dioxide, methane, oxygen, or other gases, scientists can begin to understand what kind of world this really is. No single gas automatically proves life.
Even oxygen can sometimes be produced without biology.
But certain combinations of gases could be very difficult to explain without life. That is what scientists are looking for. Not alien cities, not spaceships, not forests, but chemical fingerprints in starlight, tiny clues from a planet unimaginably far away.
And those clues could one day reveal whether life exists beyond Earth.
So, did scientists find a planet better than Earth? Not yet. They found a world that may share important similarities with Earth. It may be rocky, it may orbit in the right zone, it may be worth studying in detail. But we do not know if it has water. We do not know if it has an atmosphere. We do not know if it supports life. And we definitely do not know if it is better than Earth.
Still, the possibility is extraordinary. Somewhere in the galaxy, there may be a planet more life-friendly than ours. A world with warmer oceans, a thicker atmosphere, a calmer star, and billions of years for life to evolve.
Maybe we have already found one and do not know it yet. Maybe this planet is one of them. Or maybe the best planet for life is still waiting to be discovered. For now, Earth remains the only confirmed living world.
But every new discovery brings us closer to answering the question humanity has asked for generations. Are we alone in the universe? And if we are not, then somewhere in the darkness, orbiting a distant star, there may be another world. Not just another Earth. Maybe something even better.
Subscribe to Infinite Science for more discoveries about space, planets, and the search for alien life. And tell us in the comments, do you think Earth is truly the best planet for life? Or is there something better waiting out there?